Now, this term Cn can be written as a over 2 pi squared, bringing out this term out of the integral 0 to 2 pi omega t e to the power minus j omega t n d omega t. Now, if we go back to the intermediate concept, solving the integral of two functions which are multiplied to one another, the formula becomes, say, x of a times y of a are two functions which is integrated for dA with respect to a equals x of a integration of y of a dA minus d dA of x of a times the integration of y of a dA to be wholly integrated once again with respect to a. Expanding this equation, say m, using this formula, we get Cn to be, say, this one is our first function and this one be the second function. A by 2 pi squared remains as it is, and omega t remains like before. Here x of a is omega t, and integrating e to the power minus j omega t will yield us e to the power minus j omega t n over minus jn. Minus and dd omega t of omega t, which essentially is equal to 1, times the integration of e to the power minus j omega t times n d of omega t, which is once again wholly to be integrated as with respect to omega t. Now this becomes pi squared omega t n over minus jn minus this integral becomes over minus j n d of omega t. I have integrated only this part. Moving on to the next line, Cn becomes a 2 pi squared omega t e to the power minus jn omega t, which remains as it is, over minus jn minus, again integrating this quantity, we get e to the power minus j omega t n over minus jn squared. Now, since the whole equation is integrated, we can put on our limits from 2 pi to 0, which will yield the following expression: a 2 pi squared. First putting 2 pi over here, 2 pi e to the power minus jn 2 pi minus, putting 0 will yield this to be 0, putting and minus jn. Similarly, we also get e to the power minus jn 2 pi e to the power minus 0 jn squared. Hope it is clear. So moving forward from the Euler relation, once again we get that e to the power minus j theta equals cos theta plus, minus j sin theta. So solving for e to the power minus j and 2 pi, we get cos of n 2 pi minus j sin of n 2 pi. And as we have seen before, this value, whatever may be the integer value of n, will always become 1 and this will always become 0. So this value is equals to 1. And replacing this value in this equation, let us mark it as xa. So from xa we get Cn to be equal to 2 pi times 1 minus Jn times the period. Cancelling 2 pi, we get minus A over 2 pi Jn. So f of t can be written as n goes from minus infinity to infinity, a running sum, Cn being the Fourier coefficient, e to the power minus j n omega naught t, and omega naught equals 2 pi over t, here t being 2 pi itself, so 2 pi over 2 pi equals 1. So f of t is a summation of n equal n goes from minus infinity to infinity minus a over 2 pi jn e to the power minus jnt, which is our required Fourier series expansion, and this is our Fourier series coefficient. Now to form the series, we can put on various values of a and define the various terms of the Fourier series, and we can also convert it to the trigonometric series as I have shown you. I will not do it in this lecture, and hope the numerical problem is clear to you all. With that, ladies and gentlemen, we come to the end of our lecture. Hope everything was quite understandable. I once again apologize to you for the impeded conditions which we have to work in. So I hope you will forgive me for the poor lighting and the background noises and any other mistakes on my part. But if you face any problems in this regard regarding today's lecture, feel free to contact me in the Google Classroom platform. The lecture will be uploaded there or in the YouTube. It has not been decided yet, and hope you all have a very good day. And what else should I say? Let us be safe from the coronavirus. Times are not good. Pray to the Almighty and Good luck and Godspeed.